This is the Chemistry 101, Chapter 7 quiz review, spring 2021. Number 1, when a maximum amount of solute has been dissolved in a solvent, the solution is said to be saturated. We cannot get any more of our solid to dissolve in our solvent, so this is a saturated solution. Number 2, which of the following statements concerning solution is not true? This solution is a homogeneous mixture of two or more substances. So the solution is composed of a solvent and one or more solutes. The solutes are dissolved in the solvent. That's true. Solution has components uniformly distributed. Yes, homogeneously. Solution is likely to form when the solutes and the solvents have similar polarities. That is true. So the correct answer here, which of these is not true, is number A. A solution is a heterogeneous mixture. It is a homogeneous mixture. Number 3, which of the substance is a non-electrolyte? Those materials that bust up into cations and anions, therefore ionic compounds, are electrolytes. And ionic compounds are those things that have either a metal or a nonmetal, or cations and anions. So NaCl busts up to the sodium cation, the chloride anion. Ammonium sulfate busts up into the ammonium cation and the sulfate anion. KOH busts up into the potassium cation and the hydroxide anion. The only one that is not an electrolyte is a non-electrolyte is H2O2. That is a compound. It is not an ionic form. It's not an ionic compound. It is a covalent compound. Number 4, which of these is an electrolyte? Remember, ionic compounds bust up into cations and anions. Sodium chloride, it's an electrolyte. KOH, it's an electrolyte. Ammonium sulfate is an electrolyte. Lithium bromide is an electrolyte. Therefore, all of these are electrolytes. Number 5, nonpolar compounds are soluble in. So we are looking at the polar or nonpolar nature of compounds. Solvents, like dissolves like. So those things that are of a similar polarity nature to what we're looking at are going to be more soluble in one another. So we're talking about a nonpolar compound is going to be more soluble in a nonpolar solvent. Number 6, which ionic compound is not soluble in water? You go to your solubility charts, that first page. Look at compounds that are soluble. Drop down. Are any of these cations or anions in that first bubble? The first bubble contains all your group 1 metals, ammonium, nitrate, and acetate. Well, there is a group 1 metal. There's ammonium. There's acetate. So sodium chloride, ammonium, and your calcium acetate are soluble in water. Neither silver nor chlorine is in that first bubble. Go one to the right, to the middle. Or is either this silver or the chloride in that middle bubble? Yes, it is. Drop down. Is this chloride paired with silver, mercury, or lead? Yes, it's paired with silver. This is insoluble. Number 7. A solution is made by dissolving 3.88 grams of sodium chloride in enough water to make 67.8 ml of solution. What's the concentration of sodium chloride in units of weight volume percent? So weight volume, you take your mass in grams divided by total volume solution times 100. So you have 3.88 grams of NaCl. That's your mass in grams. 3.88 grams divided by total volume, 67.8 ml of solution, 67.8 ml times 100%. So 3.88 divided by 67.8 times 100 comes out to be 5.72%. Number 8, a solution of 12 molar HCl is diluted to a total volume of 215 ml of water. What's the new concentration of the acid solution? Key word, what word do we see? Diluted. This means C1V1 is equal to C2V2. So we see dilution by dilution. C1V1 is equal to C2V2. 15 ml of a solution, which is 12 molar, is diluted. So this is what has water being added to it. Therefore, this is C1, that is V1. We're adding to this a solution whose total volume is 215 ml. What's the new concentration of your acid solution? Notice, so we've got a V1, 15, excuse me, let's convert that to liters, 0.015 liters, 15 ml is 0.015 liters. Our initial C1 is 12 moles HCl per 1 liter solution is equal to C2. V2 is the new volume of solution. The new volume, our solute is a liquid, and our solvent is a liquid. So it's not 215 total volume, it's 215 plus 15, or 230 ml total volume. So this is 0.230 liters. So it's 12 times 0.015 divided by 0.230. None of these answers is correct. So the correct answer here is E. Number 9, circle the answer from the best available. Oops. It says a flask contains 2 compartments, A and B, with equal volumes of solution separated by a semi-permeable membrane. Which diagram represents the final level of the liquids if A is initially 10% weight volume glucose, B is initially 20% weight volume glucose? So initially, here is A, here's B. So the level of solution is equal in there. The left side is initially 10% glucose. The right side is 20% glucose. A semi-permeable membrane, meaning water can go back and forth across that barrier. Water moves from the 10% side to the 20% side because that's a semi-permeable membrane. Because there's more glucose over here, there are more things dissolved in solution. The water preferentially migrates to this side, but cannot migrate back because the glucose gloms onto it. It keeps it on this side. Therefore, over time, the water in this side will decrease. The water level in this side will increase. So here, answer is A. Finally, number 10. Of these compounds, which will be the most soluble in water? A, B, C, or D? For solubility, we're looking for something that is most like water in its nature. Water is a polar material. Water has dispersion forces. Everything has dispersion forces. Water has dipole-dipole because the oxygen is much more electronegative than the hydrogen. So we have dispersion. We have dipole-dipole. Third, we have hydrogen bonding. So whatever compound we have that has dispersion forces, dipole-dipole, and hydrogen bonding is going to be most soluble. We can easily eliminate A. Why? A has only dispersion forces. The difference in electronegativity between carbon is such that it's so small such that these bonds are considered to be nonpolar. So the only thing A has is dispersion forces. D. D has dispersion forces. Does it have dipole-dipole? Yeah, it does. Right here. This molecule is polar. This has dispersion and it has hydrogen. It has dipole-dipole. But does it have hydrogen bonding? Is there an oxygen? Is there a hydrogen directly bonded to an oxygen anywhere in that compound? No. So let's look at C and B. Everything is dispersion. Are these molecules polar? Oh yes. We have a carbon-oxygen bond here. The difference between carbon and oxygen is large enough that this has a permanent dipole. That molecule is a dipole. It has dipole-dipole forces. Does this molecule have dipole-dipole forces? Yes, it does. It has two dipole-dipole forces in there. This molecule is a dipole. Does this molecule have hydrogen bonding? Do we have a hydrogen directly bonded to an oxygen? Yes, we do. Here we have two sites of hydrogen bonding, here and there. In this molecule, we only have one right there. So C would be more soluble in water than B. And for the bonus point, the answer was, question was which one was more soluble, most soluble in water? That would be C. Why? Because we have two sites of hydrogen bonding here, where we have only one site for hydrogen bonding there. Therefore, C would be the most soluble in water. That's the Chapter 7 quiz. Have a good weekend. Take it easy. Thank you very much.